Okay, let's look at the homework 2.1, number 9. Right, so we want to find the equation of the tangent line to this curve parallel to the given line. Alright, so again, whenever you try to find the equation, you are looking for two things. First one, we need to have a point. Right, so that would be, we'll probably write it as x1 comma y1. Right, so that's what we'll, first thing you look for. And the second thing you look for would be the slope. Right, so slope, let's call it m. Right, so in this case, the tangent line we're looking for has to be parallel to the given line, so it has to have the same slope as this given line. So if you rewrite this equation into slope-intercept form, we can find the slope easily. So I'm gonna subtract x and add 6 to both sides. That way you have 3y is equal to negative x plus 6. Right, then we can just divide through by, so divide through by 3, so that I can isolate y. So y is equal to negative 1/3 x and plus 2. 6 divided by 3 is 2. Right, so you can see that this is in slope-intercept form, so slope shows up right there. Right, so slope is negative 1/3. Alright, so when you look at the derivative of this function, derivative tells you about the slope of the tangent line, so we're gonna find the derivative of this guy. So let's say f prime of x is equal to, right, so again, limit as delta x approaches 0, right, then you have to have f of x plus delta x minus f of x all over delta x. Right, so this is going to be limit as delta x approaches 0. Right, saying you have a long fraction. Right, so whenever you see x, we're gonna put x plus delta x in there. So we have x plus delta x squared minus x plus delta x. Right, and a minus, so that's minus sign right here. Then you have to subtract f of x. F of x is just x squared minus x, and it is divided by delta x. Right, so then we just have to multiply out and simplify as much as we can. Then send delta x goes to 0. Alright, so if you multiply that out, you get x squared plus 2x times delta x plus delta x squared minus x minus delta x minus x squared plus x, right, over delta x. Alright, so we can cancel out, let's see, x squared here and minus x squared here. There's a x here, and there's a minus x there, it's a plus x. You can cancel those. Right, so you can see that there are 3 terms left over, here and here and there. Right, so what we have is it's going to be a limit as delta x approaches 0. Right, then notice that every single term on top has delta x. So I'm gonna put factor out delta x, then you see that there are 2x from the first term, so 2x, and there's going to be another delta x from the second term, so that's going to be just -1, right? Then you have delta x on the bottom. So delta x and delta x cancel out, then you can plug in. So delta x goes to 0, so you have a 2x plus 0 minus 1, which is 2x minus 1. Alright, then what we want to do is we want to make sure that this derivative is equal to this given slope, so that it's parallel. So we have to solve this equation. So that happens when 2x minus 1 is equal to -1/3, right? So we solve for x, so we're going to add 1 to both sides. You get 2x is equal to positive 2/3, right? Then you can just divide by 2 to isolate x. So x is going to be 1/3, right? So if x is 1/3, so that the x1 is 1/3. So that's where the slope of the tangent line becomes -1/3. Alright, then if you want to find the y value, all you really have to do is plug in 1/3 into the f function. So you plug in 1/3 into the function. You will get 1/3 x squared, so 1/3 squared minus 1/3, right? So 1/3 squared would be 1/9, right? Minus 1/3 is same thing as 3/9, so this is going to be -2/9, right? So y1 is -2/9, right? So therefore the equation of the tangent line that we're looking for is going to be y minus y1, -1/9, so it's going to be plus 2/9, sorry, is equal to, and slope is -1/3, and quantity x minus 1/3, right? So that's the equation that we're looking for. Okay, that's it. I hope that this was clear.